This is the first video on section 7.5 cylindrical coordinates. Converting back and forth between rectangular coordinates and cylindrical coordinates is something that you already know how to do. You just might not know that you know how to do it. Okay, so the first thing I want to do is give you a brief review of polar coordinates. So if you have your rectangular representation of a point in the xy plane, we call that xy. But we can also express that in terms of the polar coordinates r theta, where r is the distance from the origin and theta is the angle that that line segment makes with the positive x-axis. And so just from right triangle trigonometry, we have the Pythagorean theorem: x squared plus y squared is r squared. X is r cosine theta, y is r sine theta, and y divided by x is tangent of theta. And so that's just a very brief review of polar coordinates, which is relevant because now definition 219, we're going to look at the rectangular coordinate of a point in 3 space, so x, y, z, and the cylindrical representation. And the cylindrical representation is simply r theta z, where r theta is the polar representation of x, y, and r2. In my notes I have a typo. I have r theta as the rectangular coordinate representation. Clearly that's false. R theta is a polar representation of x, y, and r2. And the z's are equal. And so this z is equal to this z. So converting back and forth is really the same as converting between rectangular and polar in R2. There's no real difference in difficulty level there. So let's look at two examples. They have 2 parts each. Here we are going to convert from rectangular coordinates to polar. The rectangular is square root of 2, square root of 2, 3. So let's look at the point square root of 2, square root of 2 in the xy plane. So we have the point square root of 2, square root of 2. R is 2, just the Pythagorean theorem. Also, we know we're in the first quadrant here. And so the conversion, we have r is 2. Since x and y are the same, theta is pi over 4, and 3 is equal to 3. So the z-coordinate for the rectangular coordinates and the cylindrical coordinates are the same. Here we have rectangular coordinate 0, 1, negative 5. So 0, 1 here in the xy plane, that has polar representation 1 pi over 2, and the negative 5 is equal to negative 5. In example 222, we're going to convert from polar to rectangular. Actually, I should say from cylindrical to rectangular, which in general is easier because we just have these formulas, right? If we know r and theta, we just plug those in to find x. If we know r and theta, we just plug those in to find y. And so here we have r theta z. X is r cosine theta, so it's just 3 times cosine of pi over 3. Y is r sine theta, so it's just 3 times sine of pi over 3. And z is equal to z. For b, we have negative 2, pi over 4, 6. Cosine of pi over 4 and sine of pi over 4 are both square root of 2 over 2. So here we have negative 2 times square root of 2 over 2, which is negative square root of 2. The same thing for y. X and y are the same for this particular example. And z is equal to z. So again, converting between cylindrical and rectangular in R3 is essentially the same as converting between rectangular and polar in R2.